Okay, this is the P4 paper from January 2021. It's question number 9. And if I show you all of it, this is a integration question. It's a volume of revolution, but not only is it a volume of revolution, we're also defining this curve parametrically. So that means that we'll have some parametrics and also some trig identities to sort out along the way. Let's just look at it though. So it says figure 3 is given by x equals tan theta, y equals 2 sine 2 theta. And we've got this region here, which is going to be rotated around about the x-axis. So if it's going to be rotated around about the x-axis, then we'll get a volume of revolution, and the volume of revolution is going to be, so part A, volume of revolution is just the integral of pi y squared dx between 0 and root 3 were the limits. So that's what we've got to do, but we've got our function defined parametrically. So what I'm going to do is say it's going to be the integral between two new limits, which I'll have to work out, I'll do that in a minute, of pi y squared and now dx d theta. So what that defines to me is I'm going to have to find y squared, I'm going to have to find dx d theta, I'm going to have to find those two values there, and they're telling me that once I've got all of those, I should be looking to get p as being 1 minus cos 2 theta. So the one thing I will do, I won't worry about that too much yet because there's quite a lot of work to do, but I will just remind myself that cos 2 theta, the trig identities for it are either 2 cos squared theta minus 1, 1 minus 2 sine squared theta. You can have cos squared minus sine squared, but we very rarely use that. So one of those two I'm probably looking to do, but I'm not going to panic about that now. I'm going to go and get on with the rest of it and see how it all falls out when I'm doing it. So I've got a choice to make. Do I want to do dx d theta? Do I want to do y squared? What do I want to do the limits? It doesn't matter. It doesn't matter which one you start with. I'm going to start with dx d theta. So I'm going to say over here, x is equal to tan theta, which gives me that dx by d theta then is the differential of tan, and the differential of tan is sec squared theta. Lots of things to do, so I won't worry about trying to simplify that at all. Let's just get on with the next bit. Y is equal to 2 sine 2 theta, and here's another identity there. I'm not going to leave that as sine 2 theta. There's no 2 thetas in my answer. So y is equal to 2 sine 2 theta, which is 2 lots of, there's only one possibility for sine 2 theta. Sine 2 theta is 2 sine theta cos theta. So y is actually 4 sine theta cos theta, which means then that y squared, which is the whole point, is that squared, which is 16 sine squared theta cos squared theta. So I've got my y squared, I've got my dx by d theta. I haven't worked out my limits yet. Now, I'm a creature of habit. I always tend to put the limits over here when I'm doing it. So I'm going to do that for this one as well. What are my limits? Well, going back to this thing, I've got x being root 3 and x being 0 there. So I just need to work those out. If x is equal to root 3, remember x is tan theta. So tan theta is equal to root 3. So I just need to solve that. And if I solve that, that gives me pi over 3 in radians. The other one is if x equals 0. Now we know the answer is 0 already because it told me in the question that, but let's just go through and do it. Tan theta would be 0, so theta would be equal to 0 here. So now, let's see if we can now build this up and see what we've got as our integral. So I've got that the volume is equal to, let's take pi out, and I've got between b and a are now between 0 and pi over 3. Y squared is 16 sine squared theta cos squared theta, and dx by d theta was sec squared theta d theta. So as I said to you just a minute ago, I waited till I got to this stage and now look at it because, as happens quite often, two of these things are just going to cancel out, okay? Sec is 1 over cos. So sec squared and cos squared, they're just going to cancel each other out. So what I'm actually going to have for my integral is the integral between pi over 3 and naught of 16 sine squared theta d theta. Now it's worth probably going back and having a look at this business here, but also if I can see that I've got cos 2 theta equals 1 minus 2 sine squared theta, I'm now going to use that, and it looks like the formula is going to drop out quite nicely here. So let's tell the examiner what I'm doing. Cos 2 theta is 1 minus 2 sine squared theta. Now if I rearrange that, I'm going to get that 2 sine squared theta then is 1 minus cos 2 theta. And so 16 sine squared theta is just 8 lots of that. 16 sine squared theta then is 8 lots of 1 minus cos 2 theta. So now my integral becomes, I might as well take the 8 out just to save myself a bit of time. 8 pi, the integral between pi over 3 and naught of 1 minus cos 2 theta d theta. And what were we trying to do? Oh, in fact, put the 8 back in actually, because the question said have it in the format. The integral of k times by something. Is it k? Is that what they used? Yeah, oh, sorry, p. Of p lots of 1 minus cos 2 theta. So actually in this case, p is going to be equal to 8 pi. Okay, that's the first part done. That's good. Let's just get rid of that highlighted part there. So that's part A done. And then part B says, okay, let's see if we can actually find the exact value. So in other words, let's integrate that and get the answer. So part B, the volume is actually, I'm going to take that 8 pi back out now for this bit here, between pi over 3 and naught 1 minus cos 2 theta d theta. All they're asking me to do is to actually integrate that, which is relatively straightforward to do. So it's 8 pi, integral of 1 is theta. The integral of cos 2 theta, you have to be able to do this at this stage of P4. If you can't do this, you need to go away and do a lot more practice on your basics. That works out to be a half sine 2 theta. So we're doing that between pi over 3 and 0. Did they ask for the exact value? They probably did. Yeah, the exact value. So now just chuck everything in and just tidy it all up. It's going to be 8 pi. It's going to be pi over 3 minus a half sine 2 pi over 3. That bit minus putting in 0. 0 minus a half sine 0 there. Okay, if you work all that out, 8 pi over 3, so 8 pi times 8 pi over 3 is 8 pi squared over 3. The noughts are all going to cancel out, and half lots of sine 2 pi over 3 works out to be minus root 3 over 4, but we're timesing it by 8 pi, so it actually tidies up to 2 pi root 3 there. If I've done that a little bit quick for you, then just slow that all down and have another look at that, but that's just basically subbing the values in. Okay, long question, lots of different parts of that you might want to go back and keep looking at again, but hopefully as an idea that makes sense.